I can't. Oh, I should really like open up YouTube and just. Oh, this is just a going on a rollicking start here. I'm
Well,
like,
it's
oh, maybe
definitely
I
not.
should open up. Maybe I should look at the chat as well. Probably a
Say
good idea.
it's not showing up on your homepage.
It'd probably take a few more seconds, maybe.
There we go. There's test live now.
Wait, is it test?
It is.
That's not really what I want to call it. Wait, I can't see my own stream. This is. Oh wait, here we go. Live streaming.
CPU design, digital logic.
Okay, there we go. Let us see if I can't change the name of the stream to CPU. Oh, we got someone. We got someone in the chat. Hey, hey, stealthy bong. Welcome to the stream, I guess. All right. How do I actually change this though? If I just does it? Okay, I think it changed it. All right. So let's get started, I guess.
Sounds good.
All right. Good. So today, what we're going to be doing is it's my first time streaming, and I have Albino Papa from the forums here. Say hello.
What's up, Planet Chili?
Yeah. So we're just gonna fool around a little bit with designing a digital logic circuits, and the goal is to make just a simple CPU that can execute a program that we write for it. So what we're gonna be using here is a program called Logisim, and you guys can get this. You just Google Logisim; it's out there on the internet, free, very cost efficient program because these like other programs like this they can run you a lot of money and there's a lot of bullshit. This one is really easy to use, very simple, and very free, like I said. So that's what we're going to be using. It runs on anything. It's based in Java, so it'll run on any system you got out there. And we're going to be making circuits here. Let me think. Where do I want to start? Well, basically, what we got here is our basic logic gates. You can build pretty much any kind of logical circuit you want from these three gates: your OR gate, your AND gate, and your NOT gate. Are you familiar with these, Albino
The
Papa?
and not.
Yeah.
I am actually, but only from Minecraft with the redstone.
Right, because yeah, I heard that too. Like in Minecraft, like people build like CPUs and stuff like that, right?
Yeah,
And
there's a couple of YouTube videos on them.
yeah, so I mean, it's the same basic ideas. Let me just check here. Here you can in this pane here, you can adjust the properties of the gate that you have selected. So you can set the amount of inputs. I'll talk about that later. You can set the size of it, just its appearance and stuff like that. What I want to do is just make sure everyone knows what these different gates are and what they can do. I want to go to narrow size for this. I like the smaller size gates. So the OR gate. Let me just bring out some wires here. The OR gate, it's going to output. Well, first of all, I guess I got to talk about logic levels. These wires, they can carry two different types of values, high or low. We can also call that 1 or 0. It's your quintessential binary digit or your bit. So each line carries a single bit. So it can be high or low. Let us attach to these some pins. These are input pins. These are output pins. Now we can go to this icon here and this is the poking. I call it the poker. I don't know what it's called actually. I just call it the poker. And it allows you to fool around with the simulation. So when you put this circuit out here in Logisim, it is already simulating it. And if you change something, like you change this to a 1, you see that this one, the output here, goes to a 1. This one to a 1. Both of them also a 1. So this logic gate here, its function is if any of its inputs is a 1, the output is a 1. The only time it is a 0 is if both of its inputs are 0.
Nah, don't forget about the delay, because I'm sitting here watching. I'm like, what is he talking about?
Oh, shit. Papa, you bring up a very good... let me just... oh, shit. I need to share screens with you. All right, share your screen. Let's see if I can figure out how to do this. Yeah, I want to share that. No? Share a window. This window. Start. All right, now you should be able to see what I'm doing.
Now I'm just wondering how everybody else is going to deal with it.
Well, I mean, they're also getting the audio. The audio that they're getting is delayed at the same as the video, so
Oh, okay.
so they should be fine. But for you, that's why that's why I did that whole test the other day to see if we could use Skype together with OBS and having it work fine.
Awesome.
And then I totally forgot to share screens with you. Okay, so there we go. So does that all make sense so far, Papa?
Yeah. Having the OR gate. Wait, that was OR gate or AND gate?
That was the OR gate.
Okay.
So OR is just one or the other, or both.
Right.
But you have to have at least one on. AND gate.
Right, just like the comparison OR and
Right.
code.
It's just like logical or bitwise OR in C. It's the same idea. And likewise with AND, you've got to have them both on for the output to be high. Otherwise, the output goes low. And the NOT gate is what's the NOT gate, Papa? Tell me.
NOT gate. It puts out the opposite of what it takes in.
Right. It just gives you the inverse of what you get. So if that's a 0, that's a 1. If that's a 1, that's a 0. So these are our basic logic functions. And if you have these, you can make anything. Technically, all you need is NOT and one of AND or OR, because you can synthesize OR from AND and NOT, or you could synthesize AND from OR and NOT, but that's just some dumb bullshit. We don't have to worry about that. You got these basic gates. You can make anything in the world. All the most complicated CPUs are basically made out of these gates. Well, there's one exception, but I'll talk about that later. So the question is, how, like when I was a kid, and I was interested in this bullshit, like even when I was in elementary school, but I could never fathom how you would even like make calculations out of these gates. Like I could always imagine a situation like, let's see here. Let's get out the old Photoshop. What's that? Get rid of that. All right. So let's make up a dumb bullshit scenario here, where we can use some logic gates. Say you got a tank, okay? And the tank, you can fill this tank with some, bullshit. Maybe we're in a fertilizer factory. So you're going to fill this tank up with bullshit. And you've got two sensors here. One sensor is maybe 60% full, and another one is maybe 90% full.
Right.
That's 90, by the way, in case you couldn't tell. And, yeah. You're all used to this by now, I guess.
Right.
So these sensors are going to output high when the level reaches, if it reaches 60% or over, this is going to be high. If it reaches 90% or over, this is going to be high. Now, you've got
With the amount of methane coming out of that thing, I bet you're.
Don't light a goddamn match, man. You're gonna fucking just bye bye. That's all I'm saying. So you've got a pump here, and this pump has a digital logic input to control it. So if it's high, it's gonna pump your bullshit into your tank. So I'm just making up this dumb scenario in my head here, but let's say you've got a controller, and what you want to do is you want to automatically pump if the level is below 60. So you want to automatically pump if you're below 60. When you reach the level of 60, the pump should stop. But now you have a push button. So here's the push button that you can use to pump additional bullshit into your tank above the level of 60. But when the tank reaches 90%, that's like your danger, your failsafe, and you want to cut off all pumping when you reach 90%. Now, this situation is something that you can handle fairly straightforward with logic gates, and I'm gonna demonstrate that right now. So let's say if you're below 60, you want to pump. So what we're going to do here is we are going to put a NOT gate here and put that into our OR. And so what that is saying is basically if the level is below 60, this is going to be 0, right? And that means this is going to be 1, and that means this is going to be 1. And so we're going to pump. But when the level reaches 60, this is going to get to 1. This is going to be 0, and so we're going to stop pumping. So far, so good. Now, we're going to add an additional input into this OR gate here from the manual button for pumping. So even when the level reaches, when it reaches, let's say 70%, this will be 1. Get that out of there. This will be 1. This will be 0. But if you push the button down, this will become 1, and you will still pump. So far, so good?
Okay, yeah. Either or.
Seems pretty straightforward. Now, the question is, we also want to disable all pumping when the level reaches 90%, because that's getting into a dangerous situation. You're gonna have your bullshit spilling all over your factory floor. That's not a good it's not a good situation for anyone. So we're gonna put upstream from this gate, we're gonna put an AND gate. Something bad happened there. There we go. And what we're gonna do is we're gonna invert this one as well into the AND gate. So as long as this one is 0, as long as we haven't reached 90% yet, this will be 1, and the input here will just go through to here. So if this is a 1, this will become a 1. If this is a 0, this will become a 0. So this AND gate here is acting as basically a gatekeeper to whether or not this input can actually get through to the motor. And when the level reaches 90%, this will go to 1, this will go to 0, and whatever we have here, 1 or 0, it won't be able to get through to the motor. So this final level here is going to control whether this stuff can actually control the motor or not. How does that strike you? Is that completely off the rails, or?
No, makes sense.
Okay, good.
So far.
Yeah, and this is like, when you think of logic gates, you think this is a kind of a logical situation that you could control with Boolean logic. But the question is, the question is, how are we going to do something like this? If we want, say we've got 3 bits here, 3 bits here. 1, 2, 3, 4 bits out. We want to add 2 3-bit numbers together to get a 4-bit result. So it's going to look something like maybe this. And we have to add these binary numbers together. Now, I've covered this in my C series, but I don't know how many people remember that. If you add, for example, this is binary now. If you add these two ones together, what result goes in here, Papa?
Talking about the second row
Yeah.
or second column. It would be a 1. No. Carryover.
Right.
It'd be a 0.
0. And then you carry this one over here, and you get 1. Which should be right. This is 0, this is 2, so that's 2 plus 3 is equal to 5, and this one is 4 plus 1, 5. Okay.
Right.
So this is the operation that we want to perform using only and or and not. And that's the trick. How do we get that done? So before we get into that, and this is what I'm going to cover next, but before we get into that, I just want to go quickly back into Logisim and just derive some of the other gates we're going to be using. Because like I said, we can make everything out of and, or, and not gates. But there are other useful gates that we want to use. And those gates can be synthesized out of the simpler gates. So, first off, what I want to do here, I'm going to get my good old friend OR gate. So this is a 2-input OR gate. Now, if you want to make a 3-input OR gate, all you got to do is, let me just see if I can't copy and paste that. All you got to do is chain together 2 of them like this. And then you got your output. And there is your 3-input OR gate. I put them all too close together. This is going to look like garbage. Put one more here. And the output here. There you go. And now if I poke that in there, same result that you would expect. And if you wanted to make a 4-input OR gate, you would just replace this here with another OR gate, and then you'd have 4. So you can chain and cascade your gates together to make larger input gates. With the AND gate, it always defaults to this big one. I don't like it.
Don't like the big D, huh?
Oh. It stretches my delicate membranes. That was horrible.
So someone came in when they first signed in, and they were like, just signed in, and already there's a phallic on the screen.
Oh, yeah. Well, I mean, designed by people like me, I guess. Terrible minds. All right. So here you've got AND gates cascaded together, and as you can see, you've got to have them all on to get the output like that. So, I mean, it's what you would expect, I guess. Now, generally when we're writing these things, or designing, we don't cascade 2-input AND and OR gates together. We just give you one that is like 5 inputs or whatever. It just makes it easier to draw. But it's all the same bullshit in the end. So there you got multi-input gates. It is rather phallic now that you mention it. I'm so absorbed in here I can't even come up with the dick jokes. That's why I need you here, Albino Papa. I'm glad I made the right choice.
So you're saying that gates don't normally come with multiple inputs like that? They just normally 2, or like hardware?
Well, I mean, it depends. I mean, in general, when you make like an integrated circuit, you can make them with as many inputs as you want, and every individual input that you add adds 2 transistors. Now, if you're building it from chips, like from loose chips, then usually they just have two inputs, and then you have to chain them together to make multiple input ones. So it depends on what you're using to build your circuits from. But I guess the ones that people are most familiar with are the two input logic gates. So that's why I wanted to show that you can build the multiple ones from those ones. Now there's also these gates here called NAND gate and NOR gate, and I mean they're just you take an AND gate, you put a NOT gate on the front, and then you got a NAND gate. So I mean that's just, I don't know, it's dumb, but we're not going to use those. Not going to use those mostly. Now the interesting thing here is the XOR gate. I call it the XOR gate. I don't know. What do you call it, Albino Papa?
I'm a creature of habit, so XOR is
XOR.
because it's exclusive or.
That is probably, I don't know, it's probably better. I'm probably just stupid, actually. I don't know, it's like Zoro. I was going to say it's like Zorro, but that's spelled with a Z, right? All right, whatever. Exclusive OR gate. So a lot of people, they get a little messed up if you put like if you take an OR gate here. It doesn't act the way some people would expect it to. I say some people, I'm marginalizing some people here, but no. Generally, when you say OR, like if I say, Albino Papa, you can have an apple or an orange. If you took both of them, like I'd think you're a greedy bastard, right? I'd be like, what, this fucking guy, you give him an inch, takes a mile. But in logical, OR means one of them or both of them, right?
Right.
Right. Let me just show you something here.
As long as you're offering, I get.
No, you get to see this amazing analytical diagram here. Let's see here. Analyze circuit. So if we go to table, this is another feature of the program here. If you put a circuit in here and you tell it to do an analysis, it'll give you a truth table for the circuit. So as we can see here, either one or both, they're all true, which doesn't work the same way that people would expect from, the English language, the way it's generally used. That's what the exclusive OR gate is actually. Exclusive OR means only one or the other, but never both. Not both. So you put an exclusive OR gate here, and we go project, analyze circuit, go to the table. Now we can see here, B only is true, A only is true, but A and B false. So that is your exclusive OR. So we're just going to let's make an exclusive OR from the basic logic, because we can do that. It's not that hard. So what we want to say is we want A and not B, or B and not A. A and not B, or B and not A. So at the root of that sentence we have OR. So we put an OR gate here. And then AND gate. And we'll make another one here. It's got that fat D I don't like. But I'll let it slide for today. Let's go. So we're going to connect these up together. So A, B. There we go. Now what you can do here to make life easier for yourself is you can say negate one of these, and it'll basically just put a NOT gate right in here. And that makes my life easier. So this is not B, A and not B, and then I want not A and B. So these are the two cases for when we want to output a 1. One of the cases is this one is on, this one is off. The other case, this one is on, this one is off. And then we just combine those two cases together with the OR gate to get the result. And now if we do this, that's high, that's low. So there you have your exclusive OR gate built using, your basic logic gates and or not.
Okay.
Yeah, and it's a very useful gate. Now this gate has another very useful property that I just want to quickly show off. And that is, let's chain a couple of those together. Let's see what we get. So we're gonna do that, 2 inputs, and we're gonna copy it, paste it, put it here. Beautiful. All right. Now we want one more of these here. Okay, so we've done the same thing we did before, creating a 3-input exclusive OR. So now I'm gonna put you on the spot here, Albino Papa. How do you figure this is gonna work? This 3-input exclusive OR.
Oh God. Let's see here. So one or the other. I would say, as long as the bottom one can be switched on.
Okay.
I would say if the other 2 are on, the electricity will not flow. Dang it.
Fail.
There it is.
I did that on purpose just to fuck with you. No, the interesting thing is here. Well, I mean, you could look at it just from one gate, like from the basic gates here. This one is on, but it's exclusive OR, right? So if you turn these 2 on, this one will be off,
right?
And that'll make it exclusive OR for this one. It'll be on, but that's one way of looking at it. But the best way to look at this gate, a multi-input exclusive OR, is the end result is on if an odd number of bits are turned on in the input. So if any 1 bit is on, the output is on. If any 2 bits are on, output is off. Right? Just like that. But if all 3 bits are on, output is on. And that holds for any number of inputs. So it checks the parity of your input bits and gives you a result on that. And that is a very useful property, as we will see when we create the adder. All right, so that's basically just my my introduction to logic gates. Those are all the gates we're going to be using for the most part. Now let's start building some actual useful circuits for design. Well, before I do that, I just want to give you guys an overview, a quick 1-minute overview of where we're going with this. Because a CPU is basically, you can divide it up into 2 parts. You've got your data path, and you've got your control. Now your data path is where all your number crunching is going to be happening. So your data path is connected to your buses, your address bus and your data bus, and it feeds in data from your memory, and it performs the calculations on the data, and then it outputs it back into memory or whatever. And it contains all the registers, like your general, well, if you're doing x86, your AX, your BX registers, all that bullshit. And it's where all the computation happens. The control is the thing that tells the data path, okay, now you've got to connect these circuits together so that you can perform this calculation, and you got to store the result in this register. So the control is what's actually interpreting the instructions, the machine code instructions, and performing the steps so that the data path can do its magic. So what we're going to be doing in the beginning is we're going to be working on the data path, on the circuits that do the calculations, because it's more straightforward, and so it's better for a beginner topic. And then after that, we'll look into control. That's where the fun is. I
Now,
don't.
Logisim can do that, or
Logisim can, yeah, it can do that. I mean, it all boils down to just and or not. So
okay,
Logisim can, yeah, simulate that fine.
awesome.
All right. So the first circuit that I want to go over, it's not maybe the simplest one, but it's the most interesting, is the adder circuit, which was I was just talking about that before. Where are we going here? Here we go. We want to create an adder. Now the goal is to be able to add two 8-bit numbers. Because I'm thinking we're going to try to make an 8-bit CPU here. I don't want to go too wide because it might be too much circuits for the simulator to simulate. It might lag. Probably won't, but I want to try making an 8-bit CPU anyways. It'll be interesting to see it's when we have to actually program it, because there's going to be a lot of limitations on us with only 8 bits.
Right.
So the way you go about adding two 8-bit numbers together is you basically do a parallel operation of 8 1-bit additions. So to create our 8-bit adder, first we have to solve the problem of just adding two 1-bit numbers together. And if we break the problem down like that, it becomes, it's not as difficult. It's not as mind-boggling. So what we have when we're adding basically two 1-bit numbers together is we can break it down into a bunch of different cases. Because we've only got 4 cases for the input here. We've got the case of, let's look at it. We got this case, we got this case, we got, this is not 0, this is dumb. Alright. We've got the case of them both being 1, and the case of them both being 0. So we've got 4 cases to look at here.
Mm-hmm.
That seems pretty manageable, right? So we're taking 2 inputs, and we need 2 outputs. One output for the first digit, one output for the second digit. So here we've got output is going to be 1 0, 1 0, 0 1. I don't know why I'm saying it backwards. I'm just retarded that way. And 0 0. So we've got to create a logic circuit that handles this situation. So what we're going to do is we're going to say, okay, let's just look at this here. So this one, the second digit here, it's only 1 if both the inputs are 1. So this digit is just a simple AND gate, right? It's just A and B, and that gives you this output right now. That's pretty simple. This one is a little more complicated. Here we see if it's a 1 and 1, 0. If it's a 0 and 0, 0. But if it's a 1, 0, it's a 1, 0, 1, it's a 1. So, I'm going to put you on the spot, Papa. What logical function do you think fits this, the output?
Looks like an XOR.
That's exactly right. That is an exclusive OR. So we can make our adder out of just an AND gate and an exclusive OR gate. And then Bob's your uncle. So let's try that out quickly here. So we'll get our 2 inputs. So this will be A, this will be B. We've got our 2 outputs. One of them is going to be, we're going to call it the carry, because it's the one that goes over to the next place. And this one is just the sum. And it's too big. AND gate and exclusive OR gate. Again, much too big. All right, so that goes like that. Yes, correct. Hook that up there. That one up there, and we'll do this And we'll do this, and we'll do this. All right. So let's take a look and just make sure that this is correct. So you've got 0 and 0, and that is 0, 0. 1, and the output is 1 with no carry. 1, 1 with no carry. Both of them, you get carry and a 0 in the sum. So that is your adding circuit.
Okay.
Fairly simple, right? But there is one problem, and that is when you're adding multi-digit numbers, like binary multi-digit numbers here, what you're going to have, let me just fix this up a little bit here. What you are going to have, you're going to have a situation like this, where you add these two together, 0 and 1 carry. So now this adder, if we're going to be doing these additions parallel, this adder has to add 3 binary digits together. It needs 3 inputs, because we need a carry in so we can chain together these adders to add multi-digit numbers. You can't just add parallel in isolation from each other, because you get the carry from the previous column comes over here, so you got to chain them together. And we call that a ripple adder. We'll get to that a little later. But first thing is first, we've got to fix our adder circuit, because our adder circuit can only take 2 inputs. We need a third input, one for possible carry from the previous column. So that makes our life a little bit more difficult. Let's take a look at how we could implement that. So I'm going to get out of here. And we are going to go, we're going to add one more input. So we got 3 inputs, 2 outputs. All right. Now the sum is still going to be an exclusive OR when you think about it. Let's go back to here. So you're adding 3 digits together, right?
Mm-hmm.
If the number of ones is even, this is going to be 0, right? And if the number of ones is odd, this is going to be 1. This is going to be like that. This will be like that. So it's still an exclusive OR, because it's still just checking for your parity, even or odd. So
that's the one you tricked me on.
Yes, that is exactly the one. I had a plan in mind. So what we're gonna do here, this is the carry. We'll put that there, and then we just wire up these guys here and here. Now, the sum is going to be a little trickier. It's a little trickier because before we just had an AND gate. If they were both on, then this one would be on. But now we've got 3 inputs. So, I mean, if we do the obvious thing without thinking and just create a 3 input and hook that up like that, it's not going to work because they have to all be on for this one to be 1, right? But, oh shit, I gotta change this. This program gives you 2 possible behaviors for the exclusive OR. One is when only one input is on, and one is when an odd number are on. That's the one you want. So gotcha. This is the standard way of exclusive OR works. But for some reason it defaults to that other weird one, where only one input is on. So, here, they all 3 have to be on for the sum to be 1. But that is obviously not, or for the carry to be 1. Papa.
If the carry was the top one.
Yeah. Oh, you're letting me die on stream here. Yeah, you gotta. The sum is the exclusive OR. Oh, this isn't gonna fit at all. Oh well, that's fine. And this one, this is the carry. So the carry was if they were both on. But now to get a carry, you have to have all three on. And that makes no sense at all, because if you add just 1 and 1, you should get a carry.
Right.
Right, but we're not getting that. So this solution is not going to work. So what we want to do is we want to get a carry if at least 2 are on. And the way we're going to do this is we're just going to put 3 AND gates here. Now this isn't an optimal circuit. You can probably optimize this and get it a little bit fewer gate counts. But I'm going for simplicity right here. So we're going to go like this, and like this. So what we're going to say here is if A and B, or A and C, which is a carry in, A and C, or B and C. Right. So if at least one combination of these two is on, then we want the carry to be high. And this should give us our correct answer. Let's just, we'll go to project, analyze circuit. Right. Here we go. So we got, well, the carry is over here, but let's take a look here. 1, 1, and 1, we get X and Y. I forget. I can't tell which one is the carry and which one is the... This is a... this is a terrible idea. But yeah, you get the idea. You put 2 together, we get a carry. 3 together, you get this. Yeah. Makes sense. So this is what we call a full adder, because it has a carry in, it's got your carry out, and you got your 2 bits. The one that I made before is actually called a half adder. That's what it's called.
Yeah, when I mentioned earlier about watching a video or two, that the half adder is what they went over.
Right.
And then combining those to make a full adder.
Correct. These are basic things that you gotta know. My brain stopped working for a second. I just started saying things that, don't make any sense. But anyways, so you've got your full adder there, and you can chain that together to add multiple digits. So let's try this out. Now, Logisim allows you to create sub-circuits. I'm not very good at it. But here is a diagram of our sub-circuit thing here. And you can see here when you click on a port in the sub-circuit, it shows you what it corresponds to in the original circuit, so you can kind of name them or arrange them properly. I'm not good at making pretty circuits, but that's fine, because we'll be using the built-in sub-circuits after we have designed our own. So what I'm going to do here is I'm going to try to give these just, that's huge. No, what are all these dialogues? All right, I want to make this smaller. How's that? It looks the same. There we go. Good. Okay, so now I need to... All right, so this is... I guess it doesn't really matter. A, B, and C, doesn't matter which one is which. But for the sake of sanity, we'll put one of them over here. That'll be the carry. This will be 2 inputs and 1 carry in. Now the outputs, these do matter. This one is, which one is this one, Papa?
That one was the the carry. Yeah, the carry.
Let me just think for a second. Yes, you're right.
Top one's carry. Bottom one was the sum.
Right. So we'll put the carry. We'll put the carry over here, and this will be the sum. Okay, that's fine. Now that we have this circuit here, what I can do is I can go project, add circuit. So we're gonna call this one top. And okay, now there should be a thing here that lets me make this the main circuit. Set as main circuit. Okay, good. This is the main circuit now. Now I can put this circuit. No, let me do it. No, Jesus. Good, I did it somehow. So this is the circuit we just made. This is our full adder. So what I'm going to do is I'm going to make a whole bunch of these. I'll make 4 of these. Put that there. Like that. Copy, paste. Copy, paste. So we're going to add 2 4-bit numbers together now. So we need inputs. This is going to be A. And this is going to be B down here. So that's this is going to, which one is low and which one is high? I'll figure that out later. But one of these is going to be low and one of these is going to be high. You'll see what I'm saying in a second. I'm just rambling on like a madman, but it'll all become clear eventually. Stop! I'm terrible at this routing, as you can see. But you see, we're grouping together our input signals into A and B sections here. So this is another A. Here's another B. And here's our last A. God, it's so ugly. It's like looking in the mirror. Oh, here we go. Sweet. So we've got 4 input bits for our A, 4 input bits for our B. Now, this is a carry in, this is a carry out. So that means that our low bit is down here because we're carrying out from here into here. Carries travel from low to high. So this is going to be our low, it's going to be our high. So this is low order bit, high order bit, high order bit. We're just going to chain together our carries. So this carry is going out from here into here, out from here into here. And these bits are our 4 output bits and extra 1 for the carry out. Carry in, we're going to set it just to 0. So let's go to wiring. Let's go ground. Yeah. There. Set that to 0. Always 0. Alright, now. I'm a retard.
What'd you do now?
I can't fit together all these input pins. I put my friggin' lines too close together. Yeah, it'll work. We'll get this going. There we go. That's beautiful. There we go. Alright. So now we gotta route these ones into here. It's like reliving my glory days. In university, I had a second year. It was actually a 3rd year class, but I took it in my 2nd year. And it was on digital logic circuit design. And we had a project. We had to build a fully functioning calculator. So I had to do addition, subtraction, multiplication, and division. 8 bits. And it had to fit on this device that did not have a lot of logic gates in it. It was a class of about like maybe 150 people. broken up into groups of 4 and 5. And ours was the only group that actually got the thing to fit on the circuit and to do all the functions.
Sweet.
And I don't wanna toot my own horn too hard here, but I designed the whole motherfucking thing myself.
I was gonna ask you, were you the MVP of the group?
Oh man, and I was super pissed off too. Wait a minute. Wait a minute. Wait a minute. I just after like horribly bragging, I realized that these outputs are all X's and I don't know why. Wait, why? Wait, okay, no, never mind. It's not going to full panic mode yet. We can still salvage this. Okay, so this is working. Why are these ones all like this? Jesus Christ. This is supposed to work. And it's not working. Because these are all connected, right? I'm not insane. Wait, are they not connected? Because these lines aren't changing color. Is my simulation not working? Simulation enabled. Reset simulation. Yes. Oh, okay, the tick wasn't on simulation. Okay, whew. For some reason, the simulation got disabled for a second there. I was like, oh shit, nothing's working. The world as I know it is not. All right, here we go. So what we want to do, okay, these are the low bits, these are high bits. So let's add 1 and 0 together. We get 1. We'll add 1 and 1 together. We get 2. And here we can see that we're getting a carry in from this one into here. That's generating this. All right, let's add 3 and 1 together. And we get 4. Don't you just love this beautiful little diagram here? We didn't have this when I was in university, by the way. Not this beautiful thing.
Think it would have helped any? Or?
Oh, for sure. The visualization, you can see all the lines lighting up. What you did was you built your circuit, and then you basically compiled it, and it ran the simulation not in real time. And then it gave you a timing diagram, which is like a clusterfuck of just signals, basically. And you had to read that and figure out what's happening in your circuit. You didn't get none of this shit, man. God damn, this is easy mode. But there you have it. And apparently the circuit works, right?
Looks like it.
Yeah, looks fine to me. You add the FF and FF together and you get this, which is correct. I'm going to say, without actually, going into paper and pen and checking it, it looks good to me. I feel like this is a functional adding circuit. And here you've got a 4-bit adder with carry out. And, well, optional carry in if you hook this up to something.
All right.
Right. And that is the basis of... this is probably the most complicated part of the ALU in your CPU, just the adding part. The rest is pretty simple. Well, it depends, but it can be pretty simple. Because, and this is what a lot of very simple CPUs did, you can do multiplication, for example, by just repeat adding and decrementing a value. So you don't need a dedicated multiplier circuit. Now, more advanced CPUs will have a dedicated multiplier because it's much faster than repeat adding. But for the very simple CPUs, all you've got really is an adder. And then maybe some other operations for simple logic like OR and exclusive OR. But in general, you've got your ALU and you've got your... and it does the operations of adding and subtracting, which I will go to very soon. It's not that complicated. But the other thing you're going to have in your data path is you are going to have registers. And it's going to look something like this. And you're going to have a mechanism that will allow you to connect different registers to the input lines of your ALU And when you connect them, the values that are stored in the registers, the binary, are going to be connected to the input lines of your ALU, your adder, or whatever other circuit you've got in there. And the result is going to appear here. And this result can be then taken into one of these registers. So that'll be like your operation of, this is register A, this is register B. This would be your operation of add B, A, which is add B and A together and store the result in B. And that's the basics of the data path. It's not super complicated, I don't think. What do you think, Papa?
No, it looks kind of reminds me of how my understanding of SSE, at least the early ones, until AVX, how it reuses the registers.
Right. Yeah, it's the... Wait, what do you mean?
Well, okay, like you said, add B and A, store it back into B.
Oh, yeah. That is the way that x86 works in general. They do that. Basically, they store the result in one of the operands. I think the reason why they do that, and we'll get into that a little later, is because it makes encoding the instruction a lot easier. Because the destination for the result is implied in the order of the operands. So it means you need less bits to encode an instruction. So, for example, that allows you to have your instructions, they take less space. And that was definitely a big thing back in the day when the x86 was first introduced. You didn't want your instructions taking up a lot of space because that's less memory for your data. And that'll definitely be an issue for us because we've only got, we're going to make an 8-bit CPU, so we've only got 256 bits of memory to work, or 256 memory locations to work with.
Right.
All right. So wait, why did I go off on this tangent? I've forgotten myself. We have made an adder. Now what we want to do is we want to make a subtractor. We want to be able to subtract one value from another one. And that's going to require a little bit of math. I'm just trying to think, because I've talked about this in the videos, but maybe some of you haven't seen this. So when you represent in binary, representing an unsigned number is very simple, right? You've just got, like let's say you've got a 4-digit number. Each one of these bits, this one's going to be worth 2 to the 0, 2 to the 1, 2 squared, 2 to the 3rd, so forth. That's very simple. Now with signed numbers, it's a little more complicated. Now how you generate a signed number from an unsigned number? That's the question. I'm just trying
Two's
to...
complement?
Wait, what were you saying?
The two's complement?
Yeah, the two's complement. That's the thing I'm trying to get at here, is the two's complement, as Albino Papa has let us know. The interesting thing about two's complement, because I mean, when you encode a binary number, and you want to make it, you want to make a distinction between signed, or between negative and positive. I mean, probably the first thing that would pop into your head is take the top bit and make it the sign bit. So if this is a 1, then this will be a negative number. And if it's a 0, it's a positive number. So let's just put 1 here. So this number is, the value is 2. If we did this one, the value would be negative 2. And this is one way of representing signed numbers in binary. But it's not a very good way of representing signed numbers in binary. And the reason is that the math doesn't work out in a normal adder. So if we were to try to add these two numbers together now, 2 and negative 2, the result should be 0. Whereas if we actually added them together with our fake representation, this would be the result, which is going to be negative 4. 2 plus negative 2 is negative 4, and that is obviously not correct. So the representation of just making this a straight sign bit is not going to work out very well. So what we do is, it's kind of weird, but so this is 0, 0, 0, 0. And if we subtract 1 from this, we get 1, 1, 1, 1. That's negative 1. And this is the representation that we actually use for representing signed numbers, negative numbers. We call this, like Papa said, the 2's complement. And if you, for example, let's see here. Well, I mean, let's add negative 1. Well, this is negative 1. So wait, let me just undo this. This is negative 2, dot, dot, dot. This is going to be negative 8, I believe. Yeah, that's correct. So let's say we want to add 2 and negative 2 together. So we go this and this, add them together, 0, 0, 1, 0, 1, 0, and we carry out a 1. But as we can see here, in the 4-bit result, the result is 0, which is what makes sense, right? 2 plus negative 2 should equal 0. So by encoding our values as 2's complement, we can reuse our old adder as is. We don't need a new circuit for subtraction. All we need to do is turn one number into its negative and then add those two together, and we get the result. All right. Now the way, I'm not going to go too much into detail, but the way you turn a number into its negative is very simple. So if we got 2, we want to go to negative 2. There's 2 steps you need to take. You flip the bits. You flip all the bits, and then you add 1. So we add 1 here, 0, 1, 1, 1, and that is negative 2, just as we've shown here before. So all you've got to do to negate a number is flip all the bits, add 1. Have you ever heard of that, Papa?
No.
No. So,
What? I'm kind of lost. I kind of looked over at the chat window.
oh, okay. Well, what was chat saying, by the way?
Someone asked if you could make a Android app tutorial.
I have never actually made any apps in Android before, but I'm interested in looking into it because I have an Android myself. Have you ever made Android apps yourself, or any kind of mobile app?
I can't even seem to get the SDK to work correctly for the Android stuff. So I gave up too easily.
Yeah, I don't know. I was thinking probably I might want to look into making something for mobile. But if I was to do that, I think I'd probably just go the route of Unity, because I read now that Unity, it's basically royalty free. And
Nice.
if your revenues exceed a certain amount, then you just have to basically pay for the software, but you don't have to pay a % of your revenue. So there's basically very little incentive now to try to go the non engine route. like instead of making using a pre-made engine to try to like do everything from scratch. There's not so much incentive there now. But I don't know.
Brandon Hild says Unity is great.
Yeah, I mean it runs on, and you script it with C sharp, which is very similar to C++. I don't know. Have you ever done any C sharp bullshit?
No, not really.
It's a good language. I like it. I mean, you can't get the sheer speed you get out of C++, but when you're just scripting something, it's speed isn't usually the biggest problem on your plate. All that's handled down in the engine.
Is that I mean, C sharp. Is the reason it's slow is because of the garbage collector, or is it just like a interpolated language? Or
Well, I mean, the thing is, it doesn't always have to be slow, but yeah, I mean, the garbage collector it can fire off at inopportune times, but I don't think that's the main reason why you're going to get a bigger speed improvement from C++. See, it has to compile the executable at runtime, and that doesn't allow for as much of the optimizations as you can get with straight C code. But it depends. In some cases, a runtime compiler can actually be faster because, for example, if you write some code back in 2011 and then in 2016 some new instructions come out, the runtime compiler can take advantage of those instructions. Whereas if you compiled it back in 2011, you're not going to have access to those instructions at that time.
Right, unless you recompile it.
Yeah, if you recompile it, of course you can do that, but if you're running a binary from back then, yeah.
Yeah, why would you revisit a 5-year-old project, right?
Well, I mean, usually the end user is probably not going to have access to the source code to recompile it.
Well, I was more thinking about the developers.
Oh yeah, of course they could compile it, but yeah, I don't know. There are pros and cons. In general, you can only get the fastest speed running, by making C++ codes, taking advantage of all you can get out of the processor and the advanced instructions. But I mean, it depends on your application. I'm a fan of C sharp, although I haven't used it much lately. I want to get back into it.
All right, Frank Villa asked, Chile, do you think I can become a programmer even if I have no college education?
Yeah. I mean, I've been asked that question before. I mean, the thing is like a college education, it's going to give you an advantage in terms of like credentials on paper, right? There's no denying that. But especially in the field of programming, what matters the most is your portfolio, what you can show people. If you can show people projects, like serious projects that you've actually worked on and contributed to a great deal, and you can show people results that you have achieved, that is going to be worth more than just a diploma and no real substantial portfolio. Of course, the best is to have the diploma and the portfolio, but even without the credentials from a university, you can still make it in the field of programming, more so than in a lot of other fields, I believe.
Yeah, I think I read an article a couple weeks back saying that some indie companies like Garage Games, they don't require a degree. They just want to see the result. So
Right.
as long as you can, like you said, have the portfolio to show that you know what you're talking about, they'll give you a shot.
Yeah, I mean, especially indie companies, stuff like that. They're not big rigid corporations, and they know what's up. So they'll definitely give you a shot if you can show them that you've got a passion and you've got some actual skills. So yeah, the answer is for sure you can become a programmer without a education.
All right.
All right. So back to this dumb two's complement bullshit. So Papa, how are you normally? How do you normally understand to take like a positive number and turn it into a negative number in two's complement?
Well, okay, so I guess the part that does confuse me is the fact that it does work backwards. You go from like all Fs would be or all ones. You said that is -1.
Yeah,
You
that's
say that.
-1.
I mean, that makes sense counting backwards from 0, but I guess seems like there was something else that confused me whenever you were explaining it in your C tutorials, but
Yeah, I mean, I'm gonna be honest with you. Thinking like in terms of like signed numbers and unsigned numbers, it hurts my head a lot too when I'm I'm like I know how it works, but I don't really feel it in my water, if you know what I mean. It's just kind of like this works, I know it works, and that's why we use it, but I don't have like a super good intuitive grasp of it. That's just, I don't know, that's just the way it is. I mean, I guess you don't have to know it perfectly to be able to use it, but it doesn't feel right. Like you want to be able to know something super intuitively, or is that just me? Like,
no, I mean, it seems like I mean, if a lot of the users on the forums, for instance, they um, we we always reinvent the wheel. Basically, we don't want to use the standard library templates and stuff because we don't know how they work. So we end up creating our own,
right?
and then until we're more comfortable with, okay, instead of using my own, I'll give the standard library a chance.
Yeah, and I feel like that's like not. I mean, reinventing the wheel isn't a good thing, but I feel like on the other hand, it's not a bad thing to want to be able to try to figure out how things work under the hood before you use them. And I'm not alone in this. Like, if you take a math course in university, you don't just start using mathematical theorems willy nilly. Like, they don't just tell you, this is a theorem, use it. You prove everything that you have, and then you use it. Once you've proved it, and once you understand it, then you use it to prove more complicated theorems. So I don't think it's a bad thing, but once you have actually understood it, don't keep recreating the wheel. Definitely use what's out there, and pre-made code, because you're gonna save yourself a lot of headaches that way.
Right.
Right. So this is roughly for a 3-bit signed number. I've just drawn a number wheel here. So starting off here, you've got 3, 2, 1, 0, -1, -2, -3, -4. And I don't know, it's just if you set your numbers, your unsigned, or not your unsigned, your negative numbers up this way, it means you can go continuously from 3 to -4 by decrementing by 1 every time. And that just makes the math a lot easier. Where am I here? Oh, right here. So if we flip, yeah, okay, there you go. All right. Now, the thing is, two's complement, the reason why they call it two's complement is it's so hard to explain. It's even hard in my head, but I mean, the standard way to take a number and convert it into its two's complement version is, for example, if it's a 3-bit number, you create a 4-bit number with a 1 in the high end. And this is the 2. This is the 2 of 2's complement. And you subtract your positive number from that. So if it's if you want to get -1, you subtract this from the 2 of 2's complement, and that gives you the complement, the 2's complement. So that would be 1, 1, 1. So you'd get a 1 in here, and
Wouldn't that be a 0?
well, I'm thinking if it's a boro, it goes up like this, right? So this is actually 1, 0, and
Okay.
and then you get the 1 here, and then the 1 here, and there you have it.
Okay.
But it's like, I don't know why they call it. I don't know why it's actually called the 2's complement. It's like, but I guess I don't know what else you would call it. Like this is the 2 because you add another digit, and you're basically doubling the range that you can make of numbers, right? So with 3-bit number, you've got 8 different values, right?
Right.
You add another digit, now you've got 16 different values you can create. So this, you doubled it, you've times it by 2. This is the 2. And then you subtract, you're taking the complement, you're finding the thing that adds to this to make this. But it's just a lot of bullshit, and I don't know how valuable it is to spend like hours studying this and, I don't know, learning all of the secrets of the 2's complement, becoming a 2's complement master. Because to be honest, I am not a 2's complement master, and I'm still here alive today. If I can do it, so can you. But that is it. That is the basic math of it.
I
Now-
can see myself having a large color wheel, or a large number wheel, at least until I memorized it.
Yeah, that's the thing. That's the thing. It's like, the question you're asking yourself is, do I want to memorize it? Do I need to memorize this?
Well, I mean, I suppose if your focus is the circuitry, then maybe.
Yeah, I guess you're right. I mean, it depends on
far
what you're working with, but
No, I don't think I'd ever have to know it.
probably not. But yeah, maybe depending on if you're making more complicated circuits that require calculations with 2's complement numbers, then you might need to invest a little more time into the understanding of it. But that is the basics of it. You can create a negative number by subtracting from the 2, the quote-unquote 2 here. You'd do a subtraction by hand. But obviously that's a chicken and the egg question, right? Because we're trying to create a subtractor. But if we need a subtractor to create the subtractor, that's going to be a big problem for us, isn't it?
Right.
Right. And that is where this trick comes in. The trick I said before. What you can do to get the negative of a number is you flip the bits, and then you add 1 to that result. So you flip the bits, you add 1, and you get the negative number. And I mean, that comes sort of from this wheel, if you don't think about it too hard. The opposite sides of this wheel, they're almost the 1's complement. 1's complement just means flip the bits, by the way. They're almost a perfect 1's complement, but they're all off by 1. The reason they're off by 1 is that the number wheel here isn't balanced. So, for example, if it were balanced, opposite sides, there should be a positive 0 and a negative 0, right? And the numbers should go from, for example, positive 3 to negative 3. But it's not balanced. The numbers go from negative 4 to positive 3. And the reason is because, well, one reason is a good reason. Uh, you don't want two zeros. You only need one zero, right? So two zeros is just wasting one spot for a number.
Floating point has 2 zeros.
True, floating point has two zeros, but floating point has a bunch of bullshit about like, like dividing by zero, and if the result is a negative, I don't know, negative infinity or positive infinity or something.
Yeah.
There's so
Man.
much. Oh man, I've read so much into like floating point, like gotchas and like weird little things that can mess up your code in floating point. It's like non-normalized, very small numbers or something. I don't know. It's weird. Floating point is really weird.
Yeah, I still haven't figured out what the whole denormal.
Yeah, denormal. That's what it's called.
Yeah, I don't even know what that is. So,
I looked into it. I was like, holy shit, this is a lot of bullshit. I don't even want to know. Just close my eyes and pretend I didn't see that.
you ever
But
tried? You ever tried converting to it like converting to an integer, and like done integer math on the floating point value? I guess the hex number.
wait, you mean like taking the floating point, just the binary representation, and treating it like an integer and doing operations on it?
Right, and then converting it. I mean, it supposedly it's significantly faster if you could know how it works.
Oh, yeah. I mean, that is you can cut a lot of corners that way, I believe.
It's not as accurate, but
Yeah, it's not as
it's
accurate. I mean, I remember a trick where I read once where you can do a square root, floating point square root, by doing some weird operations with a magic number that people don't even really understand that well. And yeah, it's a kind of a hack, but these days I don't think it's that important with SIMD and everything. Back in the day, when floating point was actually done on the floating point unit, and a lot of computers didn't even have a floating point coprocessor, that was definitely like a giant performance increase.
yeah, yeah. First, I think I read that John Carmack used it in Quake.
Yeah, yeah, yeah.
Came up with, or did he actually? I guess he supposedly came up with it,
I
but
think
I've
it's
also
called.
read that he.
Well, no, I was gonna say I think it was called the Carmack's reverse or inverse, something that might be something else. I'm not sure, but yeah.
Yeah, so, but supposedly the reciprocal square root in SIMD uses that.
Oh, really? I didn't know that, but
I
yeah, I
think
wouldn't
that's what I read.
I wouldn't be surprised. Yeah, for sure. Um, but yeah. Anyways, in general, you only need for integers you only need one zero.
Right.
So you got this situation here. The number wheel is a little imbalanced. So, anyways, to get the negative number, again, you flip the bits, but you're off by one, so you got to add one to that value. And that gives you your negative number. Flip the bits and add one. And this is very fortunate for us. Very fortunate. Because flipping the bits on like an array of lines here on a bus, we call this a bus, uh, is a very simple operation. Let me just let's go project add circuit. Flipper. There we go. So the way you flip those bits, we want two inputs. I'm gonna go like this, and I'm just going to create 4 of these. I'm gonna create a bunch of inputs here. Copy that.
While
Man,
you're doing that, someone mentioned that it's called the fast invert square root.
yeah, I think. Oh yeah, yeah. There's in. I was gonna say something about that, but yeah, there's two different instructions for that, right? There's the fast one, and then there's the normal one, and the fast one, the approximate inverse square root in SIMD is much faster in SSE, but it's also it's approximate. So what you're supposed to do actually is you are supposed to calculate the approximate, and then you're supposed to use like Newton-Raphson to get the actual one. But
Yeah, and as long as you keep it, I think below 2 iterations or less, you still come out on top.
right, yeah. But when I made do you remember my stupid gravity simulator? We had a whole bunch of N bodies that were rotating around each other.
Yeah.
That one, I didn't do the Newton-Raphson. I just took the approximate, and it was like, yeah, it's fine.
Really, I didn't even see that.
Yeah. So I mean, if you don't really like, I don't know. I haven't gotten a super lot of experience, but if it's just a thing for show, like if it's like a particle effect or something where it doesn't actually affect the way the game works in the physics, it's just something visual, you could probably just get away with like not doing the Newton-Raphson.
Oh, you're talking about on the SimD side of it?
Right. In the
Okay.
SSE.
Yeah, I don't think I always just straight use the
Yeah.
reciprocal square
Yeah,
root
I
and
just
then
like, oh, fuck.
reciprocate that.
Just fuck accuracy, man. I don't want to type all those extra lines.
No.
So here we've got 4-bit input, and output is going through exclusive OR gates. Now the beauty of the exclusive OR is if you exclusive OR with 0, you just get the value, right? The value that you input in the other one. But if you
Right.
exclusive OR with 1, you get the inverse of the value.
Ah, there you go.
So exclusive ORing with all 1s is just going to let you flip all those bits. So what you do is, let's get rid of this here. Go back into our good old friend top here. You take one of these. Get off my freaking pointer. And you get. Let's take the bottom one just for shits and giggles here. Get off my stuff. And what we're gonna do is we are going put a bunch of exclusive OR gates here. Copy, paste. And we're going to push our inputs through those. Get off there. I swear, when I'm just doing this stuff on my own, the circuit diagrams don't get this messy. It's the stress. It's the performance anxiety. That's what it is. I swear this has never happened before.
We all say that.
All right, let's. All right, so here we've got our. This will allow us to control our input, whether we want to flip the bits or not. Now we're gonna cook this back up into where it was before, hopefully. And that just goes here. All right. Now this is our flipper. And remember, to get the negative of a number, you have to flip the bits and add 1. Now that would seem like we would have to add another adder into here just to add the 1. But we've got this carry in that we're not using for anything. So if we just hook that up to the same thing that controls the flipper, now we basically do the flip the bits part here, and then we add the extra 1 at the same time that we're adding the other operand into here. And that allows us to subtract 2 binary numbers. We will be subtracting this one from this one. So that's at least a theory. Possibly I've fucked something up along the way. Let's see. Let's zoom out so I can get the whole circuit here. So again, if we add 3 and 1, the result is 4. Now if we subtract 3 and 1, the result should be 2. Oh shit, I fucked it up. Wait. Oh no. Okay, it's good.
Should be
I'm
3, right?
I'm subtracting 3 from 1. Okay. Oh God, give me a heart attack there for a second. All right. So adding again 1 and 3, 4. Now if I subtract, the result is 2. And this carry out also you're going to get this here, and it's going to give you some information about the operation. But it's not super important right now. But basically, depending on this bit here and this bit here, you can tell whether an operation overflows or not in a subtraction. But we won't talk about that. Anyways, and that, my friends, is how you create an add-subtract unit in an ALU. Isn't it marvelous? Are you not impressed by my majesty? I can tell you're speechless. You're speechless, Papa. I can tell.
Yeah, speechless.
Now the other thing in an ALU, this is going to be your main thing in your ALU, just your add subtractor. But you're going to have other stuff, and that stuff is going to be super simple. I mean, your logical units, like an AND unit, is just going to be literally just like a bunch of AND gates lined up and like this, with inputs going from each one into here. 2 input AND gates lined up. There's no crosstalk between them. There's no chaining or anything. It's just a parallel operation. Same thing with OR. Same thing with exclusive OR. And exclusive OR will allow you to flip the bits by just putting all ones in one of the operands. So you've got that operation.
So that's why bit shifting's so fast.
Yeah.
Or bit masking.
Yeah, exactly. Because it's super fast because there's only one stage. It also takes very little die space. It's just good all around stuff. Shifting is also fairly simple because all you're basically doing is you're connecting. For example, if I was to shift this value over by 1, you're just connecting the 0th input to the first output. You connect the first out to the second, or the first in to the second out, this one to this one, and this one just goes nowhere, right? Just goes off into space. So that is also like shifting left or right by 1. By 2 is a little more complicated, but it's not important. You don't need that. The original 8086 processor only could shift by 1 at a time. So if you wanted to shift multiple, you'd have to add multiple shift instructions.
Oh, wow.
And that is, I mean, that's all you really need in an ALU. Let me think here. We're up for time. I want to know in the chat, does anyone have any questions? Not just about this, but just questions in general about the tutorials or about the channel.
Someone said something about it'd be interesting if he makes one for ternary logic.
Ternary logic. Well, that's not going to happen. I'm not saying it is interesting for sure, but I've never looked into ternary logic. I mean, yeah, I don't know. I mean, it's not used that often yet. I think from what I've seen, I think newer flash chips are starting to use multi-level logic. But I haven't really seen anything about that for computation yet, for CPUs and stuff. I could be wrong though. I haven't looked into it that much. But yeah, the main reason why it's not going to happen is because I don't know anything about it. So that's probably one of the main requirements for me being able to teach it. But yeah, it is interesting. I think, yeah, you and I, Papa, were talking before, just in chat, about how CPUs are going to have to progress from now on. Because you've got, I mean, we're going to hit a ceiling for clock speeds, right? We're already pretty close to hitting that ceiling.
Yeah, we've been sitting between 3 and 5 gigahertz for I
Right.
think half a decade or more.
Yeah, and you can only shrink transistors so much. And so, I mean, one of the ways you're going to be able to improve the speed is, wider instruction units and stuff like that, bigger dies, and maybe stacking layers on top of each other. But you said before, Papa, there's heat problems with the stacking issue, for sure.
Mm-hmm.
Yeah. But another way you could conceivably improve performance is by increasing the amount of information that every single wire carries. So instead of only carrying 2 possible states, it could carry 3 or 4 or more.
Josh Anderson asks, "What schooling do you have?"
For me, right?
For you.
Yeah, I went to university for what is it called? Computer engineering, I guess they say. It's kind of like the bastard of electrical engineering and computer science. So I had a little bit of both software and hardware design stuff. Did 4 years of that. And then I went to Japan and did something that has no relation to my degree whatsoever.
Just followed the money.
Ah,
Or did you have an interest in Japan in general, or?
yeah, I mean, I studied the language myself for a long time. I was a huge weeb, but I wasn't like the anime weeb. I liked the Japanese like dramas, like I don't know. It was weird. I don't even know why I like that stuff. I watched the television today, and I'm like, the acting is so bad. How did I ever like this stuff? But I don't know. I guess it was something different. I like the feeling of like a different culture. And now I've gotten super used to it, so I just like to complain about Japan now.
Stephen Scott asks if your C++ tutorials are complete.
Complete? Does he mean like they're completely finished, or like do you need any other resources to? I don't understand the question.
I don't know.
Yeah, I guess you would know.
Let's see. You can use the subtractor for less than, greater than, equal equations as well.
Yeah, that's what you do when you compare 2 values. In, for example, in x86, they have the instruction compare, and all it does is it does a subtraction, but it doesn't store the result back in the register. So it just does the subtraction, and for every operation, I haven't gotten that far, but for every operation, there is something called the flags register, and that stores something about how the operation finished. For example, if you subtract 2 numbers and the result was 0, in the flags register, the 0 bit will be set. And then you can branch on that flag. So if you subtract 2 numbers and the 0 bit is set, and then you hit a jump if 0 instruction, it will jump if the 0 is set, meaning it'll jump if those 2 numbers were equal. Because the only way that the 0 bit would have been set is if those 2 numbers were equal to each other when you subtracted. So
Stephen Scott said, "Are they finished?"
Oh no! I mean, I'm still going on with them. So I mean, I'm kind of slugging on with the Hug series right now. I'm because I really want to take all the stuff we've used so far, and I want to make an actual game out of it. But I'm also brewing up a series on 3D graphics, the basic, the math and stuff behind it. And after that series is where I'm going to hit the hardware accelerated 3D, where we program the GPU. So all the setting up bullshit, and also more importantly, creating your own shaders, which is the most interesting part of programming the GPU. So yeah, it's not finished, not at all.
Okay, so the next question, I guess, you kind of answered, what do you plan for the future of your channel's content?
Yeah, basically, yeah, I answered that. I'm gonna make the 3D stuff, and also I am planning to reboot the beginner series because a lot of stuff it's sort of out of date or not really out of date, but like the tools are harder to find. And there's a whole bunch of things I fucked up that I would like to correct. So that's definitely another thing planned for the future.
Are you gonna stick with starting out with C and then going to C++, or are you gonna just go full on C++?
Yeah, that is another thing. I mean, I don't think I'd go full on C++, but in the original series, I made a conscious effort to avoid as much as possible the C++ aspects and just do mostly C, right?
Mm-hmm.
And I'm wondering now how much I should maybe change that. I don't know. What do you think, Papa?
There are some things that you could probably introduce in, like, instead of malloc, avoid either new or even unique pointer, shared pointer, stuff like that. I mean, as far as classes go, you could introduce those instead of structs, because I know that you started out with structs.
Yeah.
I don't know. I remember from whenever I started following along, I was so confused on what the difference between a struct and a class was, and it I don't know why it took so much to understand that they're the exact same thing except for the public versus private access. One has a structs have public by default, and classes are private.
Right.
Members.
Right.
So,
That's basically the only difference, right? But yeah, I guess I need to think about it some more, and then maybe I need to ask some more people. But yeah, I am thinking about maybe changing that a little bit for the reboot. Maybe not quite hiding so much of the C++ aspect of the language.
let's see here.
Wait,
Well,
Salty Tristan is laughing at me. I feel like I'm being made mocked of. I'm hilarious.
where did it go? Oh, it says Grog Puffer. Why
Grog.
do you use C++ when C# is more user friendly?
Yeah, I mean, I use C++. First of all, it's a lot of it is just personal preference. I like the language a lot more. It's a lot. You can do a lot more with it. You can do a lot more meta programming stuff with templates and stuff like that. It is, I mean, you get people on other sides, like when you talk about which language is better, you get a lot of partisanship and a lot of flame wars. But I don't know. In my personal opinion, I would say that C++ is a more powerful language. You can do more with it. That's the reason why it's less user friendly. There's just tons of more bullshit and features there to worry about. Now the reason why I use C++ when C# is more user friendly, like I said, it's my personal preference. I'm more used to the language, and just in the end, you're not gonna beat C++ for performance.
Yeah,
Yeah.
I was gonna say, I'm surprised you didn't actually say that. From what I've read, that C++ is more more widely used in the gaming industry, and since your tutorials are game oriented.
Yeah. Well, I mean, yeah, that's probably the reason why I started using C++ is because I looked it up and I was like, what are games made out of? C++. I'm like, okay, that's what I'm learning. And that's what I've learned, and now that's what I'm the best at.
Okay.
Yes,
how do you make the Chili framework? Can you do a tutorial on how you set up your windows for games?
How do I yeah.
Because see, that is one thing that I've seen brought up in the forum before, is it's one of your old posts, and you did kind of have an explanation for it, but in one of the videos you said that we would basically break down and create the framework from scratch. And
Yeah, I did say that, didn't I? But then what I basically did was I did a video where I just went over all the different parts of the framework and sort of explained how they worked, which is not the same thing as breaking it down and building it up from scratch. It does, however, take a lot less time.
Mm-hmm.
But I don't know. What do you think, Papa? Do you think you think I should make a video on that? Because I know a lot of people have been asking for it over the years.
Maybe. I think my standpoint would be maybe whenever you get around to doing the 3D hardware, starting, showing that, building your framework for that from scratch.
Right. And that is actually exactly what I had in mind when I did that. I figured, well, when I do the actual, when I do the hardware 3D series, I'm just going to start with an empty project, build everything from there, maybe make the Windows area section a little better than I did for the original framework as well. And then that'll also cover the thing that other people were interested in. But then, like, maybe 3 years later, I still haven't started that. So it's like, well, shit. I expected to hit that stage a little earlier. So I don't know.
Right.
If I do the remake of the beginners, maybe I should just put a few episodes in there where I rebuild the framework. But I don't know. When you watched that, Papa, were you confused by it? Was it super difficult to follow?
Whenever you went over the framework,
Yeah, when I just overviewed the parts of it.
honestly, I wasn't at the point where learning how to make a framework really mattered.
Oh, okay.
Just for me, I think I just wanted to get to the programming, the coding, learn that, and then on my own. And I think I had posted this in the forums as well, as if you look at your framework and then go to the MSDN website and look up those functions and see, okay, Chili does it in this order, and then kind of, once you have, okay, the MSDN will explain how, what variables are needed. You're giving basically the example, kind of helped merge, strengthen my understanding of it. And
Right.
I just kind of started adding, making my own framework from that. So, but whenever you went over it, it wasn't important to me,
All right, it makes
because
sense.
I wasn't. I basically took the framework as what you intended it for, is a jumping off point for learning how to code.
Right. Yeah, that is exactly the intention there. And that's the thing. Like, a lot of people in the beginner series, like the first episode, they're like, "Well, this is bullshit. I don't want to learn how to use someone else's framework." I'm like, "Well, that's not the point of it, dude. I mean, I'm not, I'm not telling you use this and make a game out of it and sell it. It's like, Jesus Christ, man." But I understand people want to be able to. One of the reasons why they would want to follow my tutorial as opposed to like a tutorial on Unity or something is that they want to understand everything, what's going on. They want to control every aspect of their executable, and I understand that that desire, but you gotta balance things. It's difficult.
All right.
Anyways. Sedated Snail here says, I find C more user-friendly, to be honest. I can see that. I mean, it's much simpler to just work with function stuff and to not introduce all that object-oriented stuff into the equation. But when you create very huge systems, I don't know, it's just... there's a lot of different philosophies in programming, especially these days. Functional programming is taking off a lot, I believe. And like data-driven programming paradigms and all that stuff, and different strokes for different folks. That's my opinion. If the object-oriented stuff just does not stick with you, just try a different paradigm, see how it fits on, and if it works great for you, then that's awesome, man.
Yeah, I mean, even Bjarne, the founder of C++, or one of the founders of C++, says that you don't have to use. I mean, you can use C++ functionally, but
Right.
not have to, or procedurally, I guess would be the more correct term. You don't have to use classes and all that stuff. You
Yeah.
can still.
That's one of the one of the strengths of the language is that it's primarily designed for object oriented programming, but it supports a whole wide variety of paradigm or programming paradigms, especially when you get into like template metaprogramming and with macros and stuff like that. You can make it look like a lot of different languages, and you can support a lot of different styles of programming with it.
Yeah, because I think programs like Java, I don't know a whole lot about Java, but it seems like they're strictly an object-oriented language.
Yeah, exactly. Like Java is basically like just cramming object orientation down your throat. Like you're gonna use objects and you're gonna fucking like it, brother.
Right.
Let's see here. Dismo77 says, I find using magnets to flip the bits more user friendly. Well, I mean, kudos to you, I guess. I mean, back in the day, the memory was called core, and it was actually made of little tiny magnets that were woven into a wire fabric. I don't know. I love looking at that old bullshit and just saying, holy shit, man. Let's see. Core memory. Yeah. It's like this. This is how memory used to be. Isn't that crazy?
So just what?
Yeah. And it would store the information depending on I forget what it is. But like magnetic orientation. So you'd put current through a wire and that would change the magnetic orientation of one bit in here. And yeah, so I mean, yeah, you could probably do that just by flipping the bits with individual magnets. That could, if you've got core memory. Don't recommend it, but greetings from Chile. That is meta. Magnets, how do they work? I have no idea. Electron spin, I believe. I like sticking to C++. I use an Unreal Engine 4, although making dynamic 2D arrays is a pain in the ass with C++ UE4. Stick a U struct inside of arrays inside an array. That's interesting. I have no idea. I've never like looked into Unreal Engine 4. Have you, Papa?
No, not at all, actually.
Yeah, I don't know. I mean, if I were making something and I wanted it to be like the most beautiful 3D thing in the world, I would probably go with Unreal Engine 4. But since I'm a pleb and I like 2D stuff, I would probably, if I were to use a pre-made engine, I would probably go with Unity, because it seems super easy, and that is a big plus for me. Trying to learn someone else's system.
Some of the videos I've seen on programming for Unity do seem pretty easy. A lot of it's drag and drop, and then you create scripts, C# scripts for everything.
That's interesting. Wait, I thought, Unity is also C#. I thought it was C++. I know it's built in C++. Okay, interesting. It's scripted in C#.
Yeah, I mean, at least that's the videos that I've seen. That's what
interesting.
Gone over. Sedated Snail, after watching your SSE videos, is there anything I need to know about floating point?
Floating point SSE. Well, I mean, basically, floating point SSE is easy mode for SSE programming compared to like yeah, because all of the weird like alignment bullshit and different data widths that you get, and you got to unpack and pack and shuffle your bullshit all day long. It's just with floating point, it's so straightforward. So part of me wants to say, just like if you can understand the integer stuff, then fucking you're on your way with floating point. It'll be a breeze for you. But
if you want to start somewhere easy, go floating point.
Yeah.
That's how I did it.
I don't know. Maybe I chose wrong when I decided to start off with the hardest part of SSE.
Well, yeah, and you're right. I mean, it's so straightforward. The shuffle instruction, you get 2 operands, not just one. It has min and max, so it's
Yeah.
as far as SSE2, you don't have to wait till 4.1 to get min and max in the integer side.
Right. Well, that's 4.1 when that comes out.
What's that?
Yeah, integer min max is SSE 4.
Right, but at the time I was programming on the AMD Phenom that came out in like 2008.
Ah, okay.
Before they implemented, it only supported SSE 3.
Wow, I thought they would have min max a little earlier, but geez, well, whatever. Yeah, so yeah, you're good, and I think I might at one point, do a video or two on the floating point stuff. It won't take nearly as long as the integer because I'll assume you already understand the integer concepts, and also it's just a hell of a lot simpler.
Right, especially all the. I tried making using the same procedure that you had for drawing a disk in the Chili platform.
Mm-hmm.
Try doing that using all integer SSE. So when you get down to the whole square distance, multiplying two 32-bit or two SSE registers doesn't. It basically chops it off and makes it two 64-bit numbers, and
Right.
had to do some shifting and multiple. It worked.
Yeah, but it's not fun. It's not.
It's not as straightforward.
No, definitely not. For sure.
This is
Steven.
treading back a bit, but I thought I heard you say you had to build a full game off the engine tutorials. You've been looking through it. It's going to be...
Oh, I think okay. Build a full game off. Maybe that's. Maybe he's talking about the Hugs series, because that's basically what I'm doing with the Hugs. Is I want to create a a fairly full-featured game, just using what we've learned so far. That's my goal for that series. I don't know.
So, or he could be talking about the intermediate series where the platformer.
Ah, the platformer. Oh God, that is something I definitely want to reconsider for if I reboot the series. Don't remind me.
Now, did you get burned out because of the state machine that you implemented for the character, the player?
Yeah, no, well, partially. I mean, the state.
That was a lot of work just to get a character to move back and forth.
Yes, and the reason I had an idea. Well, first of all, I kind of wanted to show the idea of a state machine, and I was just trying to think of some kind of application for that. That's one reason why I did it that way. The other thing was, originally I had planned for the game to be a lot more complicated, a lot more different kinds of states and interactions. And looking at it now, it's total overkill, because it's like, well, what you just to jump and to move, you put this whole infrastructure into place. That's retarded. But even considering that. Even granting, for example, that I would be adding a lot more states and a lot more interaction and stuff, a lot more complexity into the system, I'm still not sure that the state machine is the way to go. And I don't know, the implementation with the dynamic pointers is also, I don't know, kind of suspect. I have to revisit that.
I had asked to work on a project with one of the board members, Mr. Godin, and in that project that he was doing, he I guess he kind of took it as canon, because that's how he was implementing all of his character movements and stuff.
You see, that is the problem that I did not foresee properly. I didn't think far enough ahead. Is that if I use these techniques, because I want to show off like a certain aspect of the language or a certain programming idea. If I use these techniques, some people are going to think that that's the way you do it. And okay, now you got to do this way every time, when I was just using a bullshit example to show off something I wanted to show off. I was like, oh shit.
Yeah, I quickly stopped trying to make my characters move like that.
Yeah. Regrets.
Well, I mean, it's good to know. It's just
Yeah, it's stuff you learn, like even if you're going to like university or whatever, you learn this stuff. And state machines are applicable to areas like AI, where you want to kind of model some kind of behavior. You usually use state machines, something like that. But
yeah. I mean, if I would say a state machine would be good if you're needing. I mean, like in a other than AI, or basically if you're needing the result to last multiple frames.
right. Yeah, that's true. That is true. Game Maker Studio. Have you ever tried something like that? Game Maker Studio.
I believe so. Yes.
Really?
Game Maker Studio.
I don't know, I'm so up my own butt about, like, I just love the programming aspect, but I feel like, because I sort of have an idea for a game that I want to make, but if I'm going to actually make it, I've got to get more serious about, like, just finding some tools that can make my life easier. So I don't know.
Like the DirectX toolkit and
Yeah, well, like more to the point, like maybe even using Unity or something.
like a whole engine.
Yeah, like a whole pre-made engine. Because if I do the thing I want to do, I want to be able to make it multi-platform for. Oh, I clicked on someone's page here. I want to make it multi-platform for like mobile and stuff like that. And trying to code mobile by hand, like maintaining a separate, build for C++ for PC, and then another one in, maybe Java or NDK for Android, and then another one in Objective-C for iOS or whatever. That's just fucking, oh, that would break my brain. So yeah, in that case, if you want to target multiple platforms and simultaneously maintain your sanity, you'd probably have to go for something like Unity or Unreal Engine 4 or something like that.
So why are less is no. Josh Anderson, I dare you to go to your history.
Not happening. Actually, right now, if I went there, it'd be full like 90% of Filthy Frank videos, and those are just disturbing. Have you ever seen that guy on YouTube?
That doesn't sound familiar.
Well, probably just forget I ever said anything.
Things you should never Google, right?
Yeah, exactly. Oh God. All right. How do you make a wrapper to convert one language to another? What?
Bytecode, maybe?
Convert one language to another?
Are you talking about programming language or?
I don't know. Like, you mean like source code or something? Because I don't think you can wrap one language into another, can you? You'd have to like write a compiler that would read the code in the one language and then output the code for another language.
Right. I mean, I think like Java and their just-in-time compiler, because they.
Oh yeah. Well, I mean, yeah. It's basically
it works on multiple systems using a virtual machine, I guess.
If you're making something that converts one language to another, you're writing a compiler, right? Like converting, for example, C into machine language, or converting C++ into assembly or something like that. These things exist, so I guess it's possible. Wrappers to convert code, like you can wrap, for example, you can wrap code that was originally designed for Linux to run under Windows or something like that, but they both have to be C, right? It still has to be C code. Your wrapper language and your original language has to be C, right? You can't take Java code and then wrap it to work in C unless you're doing something
Interpreter.
on the binary level, but not in like just source code. Like just include, whatever what is the Java? I forgot the Java extension? Just Java? .java?
Yeah, it's .java.
Oh God,
I think it's their binaries.
it's been like 10 years since university now. I'm old. I forgot Java. Yeah, like wrapper, like when you have a wrapper that allows you to use a C library and something. Ah, okay. Uh, well, I mean, Python. Yeah, Python allows you to call C like library functions and stuff like that. Like that's a part of the Python language already. You don't. I mean, wrapper. I suppose. I mean, it's possible to write. I don't know if you'd call it a wrapper in that situation. It's just
Right.
you're basically defining entry points into a C binary from Python. But yeah, I don't. I mean, I'm not familiar with Python, so I wouldn't know how to define those entry points. But yeah, like C++ library to C# or Java. Hmm. And that would be something you would have to, like, if you were starting with a C++ library, you want to call it from C#. I'm pretty sure C# gives you an option to call. I don't know about C++, but you can probably call C functions from that. But that's something that's handled on the calling side, right? So that's Java would be weird, but I think there's a way to to maybe call native code from Java, but I wouldn't know how to do it, and it wouldn't be a good idea because one of the benefits of Java is making it portable, right? But then if you make
Hmm.
it depend on something that's native, it's no longer portable. So it's not a good idea. Yeah, using OpenGL and Java, I mean, Java supports interfaces for interfacing with OpenGL, right? So you wouldn't want to hack your own way into calling native code when Java gives you something, an interface to use.
Yeah, I think Java does have. Uh, I think it even has DirectX libraries, or
Yeah, yeah, yeah.
maybe.
Java? I don't know. I think maybe. I mean, it's possible. There's probably gonna be some way for like Java to interface with the native code and to call native functions, but I wouldn't know much about that. So
Right.
you'd have to consult the implementation for the specific language that you're using. Although, I mean, if to go at it from the other side, I wouldn't know how you would want to call like a Java function from C++. You couldn't just call the function, right? You could tell the computer to run a Java program, but single functions, I don't think you can do that from C++ because it's a whole different bag of worms, right? You're running off bytecode then.
Yeah, I was gonna say because like C++ mangles what they call it name mangling
Oh
for
yeah,
functions. So it'd be
well, there's that too. But even before that level, I mean, binarily they're completely incompatible. One is bytecode, one is machine code.
oh yeah, right.
So I don't know. Writing a wrapper, different languages. I mean, you generally wrappers are generally you wrap a certain API to run in a different language. So, for example, you can have an API and it can define standard entry points for which like a C program or a Pascal program could call, right? And now you want to make a wrapper so that it looks better in C++, make it object oriented. So you wrap those just basic function calls in objects and stuff like that. That's generally the idea of talking about a wrapper.
See, the only thing that comes to mind when I think of wrapper, I think of you ever heard of Wine on Linux?
Yeah.
Windows and Linux. Um, basically, they have the for like DirectX library. They have names with the same named files. I would imagine that they have those entry points. The functions are the function names are the same, but behind that, the actual implementation is specific for Linux itself. You know, maybe calling a similar OpenGL function.
Right. Okay. Wait,
That's what I would think of in a
so
wrapper.
wait. There's wine, and what's the other one for if using the GCC compiler to compile Windows code? What is that? Sigwin or something? Yeah, Sigwin, I believe is what it is. Yeah. So
Mm-hmm.
Wine is basically emulating Windows environment under Linux, right? Providing the entry points for a Windows program. Am I correct?
Right.
Yeah.
That's the way I understand. Yeah.
Yeah, that's a little different than a wrapper. That's almost like a emulation kind of problem, but I don't know. Sigwin. Yes. That is the one. All right. What other questions we got here?
Are you gonna post this video so I can watch it later?
Yeah, it's going to go up automatically, so there's no problem with that. What else we got here? There's some stuff up here that we kind of skipped. Something about toy. Feel stupid. Here we go. Okay. Yeah, dare you to go to. No, it's not happening. Free channel ad for sedated. Do you wait? Do you know how to change an array of XYZ to XY given camera position XYZ? Well, that's projection, right? That's what you're talking about here. Wait, angles for angles XYZ. I don't understand angles XYZ, but basically going from XYZ to just XY is your that is your what do you call it? Your projection matrix, right? So you're doing the whole homogeneous coordinates bullshit, and you're using your Z value to basically scale your X and Y so that it looks like there's a perspective. And I do know how to do it, but it's a hard question to answer in this format. That is going to be a good part of the series in just talking about 3D graphics theory. That'll be a good one episode there by itself, I think.
User on the forum JDB and his ray tracing program, he uses instead of using matrices like you would normally in DirectX and OpenGL, it's all vectors. So like he negatively rotates the camera. Well, okay. I guess he subtracts the position of the camera from the position of the object, and then negatively rotates the result to bring the object in front of the camera, and then subtracts. And I can't remember how the rest of it.
All right. Well, what you're saying
yeah,
sounds.
he basically uses all vectors instead of using
Yeah.
setting up the view matrix.
Yeah, I mean that's one way of doing it, right? But the problem is you got to do that all those vector transformations for every point in your model, right? So the benefit of using a matrix is that you can put all of the operations into one matrix, and then you just have to multiply by that matrix every single time.
Right. That way, you're only having to call your sine and cosine function
Right,
once
right.
for the object, and not
And
for every.
I guess the main benefit of that, especially is in hardware, is hardwired to just do matrix multiplications. So you're not going to gain any benefit from doing them separately. It's going to do a matrix multiplication whether you like it or not.
Right.
But yeah, in the end, I think it's about the same thing.
But yeah, as far as converting the three-dimensional coordinates to two-dimensional screen coordinates, just dividing by z is plenty.
That's basically how it works. Like, I mean, in actuality, like in real implementations, there's this bullshit with homogeneous coordinates that comes into play. But in the end, essentially, you're just dividing by z, right? Objects farther away tend to be squished closer towards the center. That's how you get perspective, whatever you call it, 1 point perspective or whatever it is.
I think as far as the homogeneous coordinates, I think one of the things I read on the MSDN website is that it's mostly used for later on if you want to implement fog.
Oh, yeah.
Or no, there was something else. It has to do with the view frustum.
Mm,
It helps lineariate.
right.
Basically, it helps evenly spread um, the depth values between the vertices closest to the camera
Uh,
and vertices further away.
I've read some things like that as well. I mean, I'm not even certain. A lot of people who do the programming, like who make their own engine or fool around with 3D, I've read online. A lot of people they just kind of use the homogeneous coordinates. They don't even really know how they work. And personally, I'm not super up on it, so I'm gonna have to do a lot of studying on that before I try to present it to people. I want to know it back and forth before I try to present it, for sure.
I think that's why I suggested we could do a 3D a software 3D using SSE and multi-threading. But yeah, a lot of people are probably ready for hardware from you. So
Yeah. Tom Sather says Xamarin can ease development across platform apps, and I've seen this. I think when I installed Visual Studio on one of my other computers, I don't remember where I saw it, but I saw something about Xamarin. I'm like, what is this? I don't understand it. And I looked it up, and yeah, it was you can build iOS from Visual Studio now for some reason. I don't get it, but I'm interested in what it is. Does DirectX feel as state-based as OpenGL does? I don't I don't think so. I mean, DirectX is very object-oriented. I believe that OpenGL, from what I've seen, and it might be different these days, but you call functions and they change the state of the OpenGL state machine, and whereas DirectX has objects that maintain the state. But I don't know. It does definitely feel a little bit different from what I've seen in OpenGL, but I believe it is changing. I don't know. Have you coded any OpenGL, Papa?
no, I haven't coded any OpenGL. I haven't even no, I haven't even looked at it at all.
Yeah.
But uh, that's why I really can't answer or even help with the question because I don't know. I don't know how OpenGL handles the rendering pipeline. You know, I mean, I know DirectX. You basically you send it you initialize your resources. You update. I mean, DirectX still has those set functions to set the state of the pipeline.
Yeah. Yeah,
But
definitely. Because I mean,
once you set the state, you hit you called your draw command, and then once you've drawn everything, you present the frame.
OpenGL and DirectX, I mean, essentially, either way, the underlying hardware is going to be the same, so there's going to be a lot of similarities either way. Different drivers can allow for a little bit of difference under the hood, but generally, it's the same idea, I believe. Wait, you said Zed. Are you British undercover? No, I'm Canadian. So, wait, that's how we do things. Although I live in Japan, so I don't know. It's weird.
I've actually heard other people claim Canada and say Zed, or even Australia.
Australia is Zed too. Yeah, interesting. Well, yeah, I guess we're all from the Commonwealth, so I guess that's the way it works.
Yeah, I think the YouTuber his name is what is it? Creel is the YouTuber's name from Australia that said that.
Oh, okay, cool.
He goes over some floating point like the fast inverse and some SIMD theory.
Patel Sharvak says, "Can you make a series on GPU design also?" Maybe. I think we'll stick with CPU for now, and then we'll see how it goes. that is quite ambitious.
Yeah, the whole time you were doing that, I was like, where's the SIMD going to be?
No SIMD. There's not even going to be a multiplier in this motherfucker. Steven Scott says, "Do you think you could come up with your own computer language?" I mean, I guess so. It'd probably be really shitty. It'd be a really shitty computer language, but it's possible. When we make the CPU, we're going to have to come up with our own instruction set and instruction set encoding, and that's almost like making your own computer language. COM interfaces you can call Yeah, a lot of C sharp code from C, but this is ugly. Oh, interesting. Yeah, I might have seen that before, using com to call managed code from unmanaged code. And yes, it is very ugly. Com is just ugh. I don't like com. I'm just gonna say that. And yeah, and CLR is the other way of doing it too, which is probably prettier. But then you have to use CLR. Do you have another job other than YouTube? Yes. If I didn't, I would have been starved long ago. I don't monetize any of my videos. The only video that's monetized is, I believe, the first one, and that one is because of the you remember in the very first video where I tell them there's just, when you run the program you get a black screen and then it comes up with that music video from
Yes.
that. I got a strike against me.
I got suckered into that.
Yeah.
It's like all I get is a black screen. I didn't get the I'm black, yeah.
Yeah. Well, as it turns out, the owner of that copyright basically,
Flagged you.
yeah, they flagged me and they get all of the revenue from that video now.
Oh.
So I mean, yeah, and enjoy, I guess. I don't know.
Nice.
All right, what do we got? What do we got? Oh yeah, it prevents z from dividing by itself. This is talking about the homogeneous coordinates, and that is true. It gives you a point to infinity, which you can't have with normal dividing by z. And I believe that's useful for some reason, but I forget. And maybe Sedated Snail can teach us.
Stores a copy of Z and W.
Yeah, yeah.
Huh. I think whenever I made my 3D engine, I just used Z, like, since I was using SIMD or SSE, I just copied Z to the 0 and 1 slots, and then copied W to the 2, 3 slots.
Yeah.
It just that way I'd copy or divide Z by W. I figured that's what they were referring to.
Maybe. I'm not sure. Xamarin. The point of Xamarin is that you can maintain one code base for Android, iOS, and Windows. Yeah, that actually sounds really enticing. I'll have to look into that. But
Is it a IDE or is it a?
I think it's like a platform. I believe you use Visual Studio as the IDE, and the language I'm not sure. But maybe it's C++. I don't know. If it is, that'd be cool.
Yeah.
I always mix Z with C somehow. I don't know where you get the C from. I mean, there's no C, dude. You're doing it wrong. I can't.
Can't help you on that one. New lane called GI.
I heard that he was making his own language, but never seen it.
I think he's come quite a ways.
That's interesting. I don't think I'll ever look into it, but
I did. I don't. I mean, he makes a couple of logical points why he dislikes C or C++. Just that I think he's really against classes. But the one of the things that he brought up was the template of the unique pointer, and the fact that the pointer part should be tied to the type, not the other way around. The type is typed to. I mean, because when you do a unique pointer, it's no longer, you can no longer use it for polymorphism.
Right. Wait.
Correctly, because it's no longer an int. It's a unique pointer that stores an int.
Right. It's a unique pointer, and it's a unique pointer to int. It's templated to int, and it points to an int, right?
Right, but it's not. I don't know. I don't think polymorphism and ints work very well, but
yeah, I mean, yeah, I don't get that part of it, but I use unique pointer and polymorphism all the time.
Example, but,
weird. I don't know. I'd have to.
But like, you can't just cast a unique pointer to another, right?
I'm pretty sure I do that in some of my code, so that's weird.
Really?
I don't know. Maybe I'd have to look at what he's saying and also look at what I did before. But I use polymorphism with unique pointer all the time, so it's weird. Interesting. Maybe if you
So, I
maybe,
mean, do you? I mean, whenever you do it, do you just cast from like the get function, or do you cast directly
well,
from
when
the?
I pass the unique pointer, but yeah, I'm pretty sure I don't know how it works, but I'm pretty sure under the hood with the templating there, you can pass like a unique pointer. You can pass a reference to a unique pointer to a child type to a function that accepts a unique pointer to parent type. I
Mm-mm.
but I might be wrong. I can't say this. I'd have to look over my stuff again to see how I did it. But I think you can do that. I don't want to get my balls exposed on stream here though. So I'm gonna say let me check my shit first. But yeah, no. If you could send me a link to that thing that he was talking about, that'd be interesting. I might want to look at that.
All right.
Oh shit. Dogrob96 is saying, "Can you please get back to CPU design?" I'm sorry, bro. We kind of got off topic here. I'm probably gonna end the stream very soon, so I am just looking through the comments here, just kind of answering questions and chilling out for a while before we end this stream. But I will
Things you know. Does ethics ever come up?
in ethics. Nope. I can't say that. I can't say that hasn't. I don't know what does he think I know? That's what I want to know. Like, what do you think I've done, Steven Scott? What do you know?
What do you know he knows?
Yeah. Yeah, Josh Anderson has it here. I think you finished CPU stuff for today. What is my line of work? I work as a translator. I translate patents from Japanese into English. It is an okay job. It is acceptable. It keeps me fed, unlike YouTube, which feeds me nothing.
Oh, that reminds me. Did you ever? I believe one time you said you were making a piece of software that helped you with that. You ever?
Yeah, well, I mean, I've gotten it working fairly well, but I've kind of put it on the sideline for now. The thing that it does is it matches up Japanese and English specifications, so it matches up the paragraphs to each other, which paragraphs correspond to which makes my job a lot easier in certain situations. So it was an interesting problem. It has to read the Japanese version and the English and find a correlation between the two sections with language and doing a whole bunch of bullshit AI stuff. But yeah, I got through that a little bit. All
Have you
right.
made any multiplayer tutorials?
Yes, the Hug series I'm going to put in their 2-player local is going to be definitely part of it, and if people want, I will go into doing online, networked multiplayer, but only if people want, because it's probably going to take a little bit. It's not a super easy topic, as you might understand, and some people might just want me to get over with the hugs as soon as possible and start on the 3D.
Well, I know you produce videos a lot faster when you're excited about the topics.
That's true. It is true, and yeah, haven't been making that many lately, but I've got stuff coming up, so expect videos in the future on the Hug series, and hopefully also on the reboot. Although the people here probably aren't that interested in the reboot. Yes. All right. So I think we're gonna close up the stream for now. Thanks, Papa, for showing up, and everyone in chat.
Thanks for having me.
I enjoyed it. And what do you think? What do you think, Papa? Are you interested in joining another CPU session, or are you all burned out from this one?
Oh no, this was fun.
Okay, great. I'm glad. I'm glad that some people were saying, please get back to CPU design, because I was afraid. I wasn't looking at chat when I was doing it. I was afraid like everyone was just like fucked off and like, what is this bullshit? Oh, get me out of here. So I'm glad some people were into it, and I definitely want to continue with it. But yeah, until next time, I will see you guys later.
All right, Taylor.
Wait, I gotta figure out how to stop the stream. Last time we did the test, I left the stream up for like 3 minutes, and I was just talking to my girlfriend in Japanese, and people are like, "Holy shit, Chili speaks another language." It was
It's
weird.
funny. I didn't hear you. I heard her. I was like, oh, there's a girl over there.
All right.